Commander Jake Morrison stood at the big window of his ship Columbia and looked at the strange alien ship floating in space. The alien ship was like nothing he had ever seen before. It was made of crystal and metal that formed perfect shapes. Every line was straight. Every angle was exact. The whole ship looked like someone had used math to build it instead of imagination. Jake had been in space for 15 years, but this was his first time seeing an architect ship up close. The architects were the best builders in the galaxy. Everyone said so. They could make anything and make it perfect. Their cities were perfect. Their ships were perfect. Everything they touched became perfect, but they did not think humans were good builders. Chief Engineer Lisa Carter walked up to Jake and shook her head. She held a thick report in her hands. The report had come from the Galactic Council 3 days ago. It was full of bad news about human building methods. Lisa opened the report and read from it. The architects had looked at human cities and called them messy chaos. They looked at human ships and said they used too much fuel. They looked at human factories and said they wasted materials. The report used big words to say humans were bad at building things. Captain Ryan Bell came to stand with them. He was older than Jake and had seen more of the galaxy. His face showed he was not happy about the report either. Ryan pointed at the alien ship. He told them the architects had sent a message. The message said humans needed to learn how to build things the right way. The architects would teach them. They had built something new called Synthesis Station. It was supposed to be the most perfect thing ever built. The humans were invited to come see it and learn from it. Jake thought about what the architects had said about human building. It was true that human cities looked messy from above. Roads curved around hills and rivers. Buildings were different sizes and shapes. Some streets were wide and some were narrow. Nothing followed a perfect pattern. Human ships were not perfect either. They had backup systems for their backup systems. If one thing broke, there were 2 other ways to do the same job. The ships used more fuel than they needed to because they carried extra equipment that might never be used. Lisa had worked on many human ships and buildings. She knew they were not perfect like architect things, but she also knew they worked. Human buildings stood strong in earthquakes. Human ships came home even when half their parts were broken. Human factories could change what they made quickly when needed. The architects did not understand this. They only saw waste and mess. They saw problems where humans saw solutions. Troy Johnson was the ship's engineering specialist. He had read every page of the architect report. He told Jake that the aliens thought human redundancy was stupid. Redundancy meant having extra parts and systems that did the same job. The architects said this was wasteful. Dr. Amy Parker was the ship's science officer. She had studied architect technology for years. She explained that architect buildings used exactly the right amount of materials, no more and no less. Their ships used exactly the right amount of fuel for each trip. Their factories made things with 0 waste. It sounded good, but Amy had always wondered what happened when things went wrong. Perfect systems were perfect only when everything worked exactly as planned. Real life was not always perfect. Lieutenant Ben Davis was the ship's tactical officer. His job was to think about problems and dangers. He had looked at pictures of architect cities and ships. He noticed that everything had only one way in and one way out. There were no extra paths or alternate routes. Ben thought this might be a problem, but he kept quiet. The architects were much older and smarter than humans. They had been building perfect things for thousands of years. Maybe they knew something humans did not know. The Columbia started moving toward Synthesis Station. The station was 3 days away at normal speed. During the trip, the human crew studied everything they could about architect building methods. Jake read about architect mathematics. Every curve was calculated. Every angle served a purpose. Nothing was random or accidental. The architects used computers to find the most efficient way to build everything. Lisa studied architect engineering. Their systems were like clockwork. Every part worked with every other part in perfect harmony. There were no conflicts or wasted motions. Energy flowed through their machines like water flowing downhill. Ryan looked at architect city planning. Their cities were laid out in perfect grids. Roads were straight lines that connected important places by the shortest possible route. Buildings were placed where they would use the least energy for heating and cooling. The more they learned, the more impressed they became. The architects really were amazing builders. Their methods produced results that humans could barely imagine. Everything worked better and used less resources, but Jake still felt something was missing. Architect designs looked perfect on paper, but they felt cold somehow. They were like beautiful machines instead of places where people lived and worked. Lisa agreed. She had seen human cities that grew naturally over time. They were messy, but they felt alive. People had built them one piece at a time, solving problems as they came up. The cities changed and adapted as needs changed. Architect cities looked like they had been built all at once according to a master plan. They were efficient, but they could not easily change if circumstances changed. As the Columbia got closer to Synthesis Station, the crew could see how massive it was. The station was bigger than most cities. It housed thousands of workers who manufactured goods for the entire sector. The station's shape was geometrically perfect. It rotated slowly to create artificial gravity. Solar panels covered its surface in precise patterns that captured every bit of available sunlight. Not a single photon of energy was wasted. Jake felt both excited and nervous about visiting the station. He wanted to learn from the architects, but he also worried about what they would think of human methods. The report had made it clear that architects considered human building to be primitive and wasteful. The crew prepared for their visit. They would spend 2 weeks at Synthesis Station learning how the architects built things. Maybe they would discover that the architects were right. Maybe human methods really were wrong and inefficient. Or maybe they would learn that there was more than one right way to build something. The docking bay of Synthesis Station was unlike anything the humans had ever seen. Every surface was smooth and clean. The walls met at perfect right angles. Lines of light marked exactly where ships should park. There was no wasted space and no decoration that did not serve a purpose. Ambassador Velthara met them at the airlock. The architect was tall and thin with skin that looked like polished metal. When Velthara spoke, a small device translated the words into English. The voice that came out was flat and emotionless like a computer reading numbers. Velthara welcomed the humans to Synthesis Station, but the words felt cold. There was no warmth in the greeting. The ambassador explained that the humans would see how proper engineering worked. They would learn why architect methods were superior to human methods. Jake and his crew followed Velthara through the station's corridors. Every hallway was exactly the same width. The walls were the same color throughout the station. Lighting panels were spaced at precise intervals to provide exactly the right amount of light with no waste. The floors were marked with colored lines that showed the most efficient routes to different parts of the station. People followed these lines when they walked. No one took shortcuts or wandered around randomly. Lisa noticed that all the corridors were straight. There were no curves or interesting shapes. When they needed to change direction, the corridors made sharp 90-degree turns. It was efficient, but it felt mechanical. Their first stop was the Atmospheric Processing Center. This was where the station's air was cleaned and recycled. Velthara explained how the system worked with obvious pride. The processing center was a maze of pipes and filters and machines. But unlike human systems, everything followed logical patterns. Each pipe was exactly the size it needed to be for the amount of gas flowing through it. Every filter was placed at the optimal position for maximum efficiency. Dr. Amy Parker asked questions about the system. She learned that it recycled 99.7% of all gases. Almost nothing was wasted. The system used very little energy because every component was perfectly matched to its job. Amy was impressed, but she also noticed something strange. Every pipe had only one path. If gas needed to go from point A to point B, there was exactly one route it could take. There were no backup routes or alternate pathways. Velthara noticed Amy looking at the pipes. The ambassador explained that backup routes would be wasteful. The system was so reliable that backups were not needed. Proper maintenance prevented failures before they could happen. Troy Johnson was taking notes on everything he saw. As an engineering specialist, he understood how impressive the architect system was. Human atmospheric systems used much more energy and wasted more materials. But human systems also had many redundant pathways and backup systems. Troy asked what would happen if one of the main pipes broke. Velthara said that proper design prevented such failures. The pipes were made from perfect materials using perfect methods. They would last for centuries without problems. But Troy had worked on human ships for many years. He knew that things broke no matter how well they were made. Space was dangerous and unpredictable. Even the best systems sometimes failed. Lieutenant Ben Davis was thinking about the same thing. His tactical training made him look for potential problems. He saw that the atmospheric system had single points of failure. If certain key components broke, the whole system might stop working. Ben kept his concerns to himself. The architects had been building things for thousands of years. They must know what they were doing. The tour continued to the manufacturing section. This was where the station built complex equipment for export to other worlds. The manufacturing bay was enormous and filled with machines that worked with perfect precision. Robots moved in precise patterns, never wasting motion. Each robot knew exactly where to go and what to do. They never got in each other's way or made unnecessary movements. The choreography was beautiful to watch. Raw materials entered the bay through one set of doors. Finished products exited through different doors. The flow of materials was carefully planned, so that nothing ever had to wait or move backward. Lisa watched a machine building electronic components. Each part was made to exact specifications with zero tolerance for error. No materials were wasted. No energy was used unnecessarily. The finished products were identical to each other down to the smallest detail. It was amazing, but also somehow disturbing. Human factories were messier and less efficient. Workers sometimes made mistakes or found better ways to do things. Each product was slightly different because humans were not perfect machines, but human factories could also change quickly when needed. If customers wanted something different, human workers could adapt their methods. They could solve unexpected problems and make improvements on the fly. Architect factories seemed less flexible. They were optimized for one specific task and did that task perfectly, but changing to a new task would require completely reprogramming all the systems. Captain Ryan Bell asked about this. He wanted to know how quickly the factory could switch to making different products. Velthara seemed confused by the question. The ambassador explained that the factory was designed to make specific products in the most efficient way possible. Changing products would reduce efficiency. It would be better to build a new factory for each new product type. Ryan found this hard to understand. Human factories often made many different things in the same facility. They sacrificed some efficiency for flexibility. It seemed like a good trade-off to him. The next stop was the power generation center. This was the heart of the station. Massive fusion reactors provided energy for everything on the station. The reactors were works of art as much as engineering marvels. Every component was perfectly designed and perfectly placed. Magnetic fields contained the fusion reaction with mathematical precision. Energy flowed through superconducting cables that had zero electrical resistance. The control room overlooked the reactors through thick, transparent walls. Displays showed thousands of measurements and readings. Every number was exactly where it should be. Nothing varied from optimal parameters. Engineer Kolnath was in charge of the power systems. Like all architects, Kolnath spoke in precise technical language. The engineer explained how the reactors achieved perfect efficiency by maintaining exact conditions at all times. Lisa was amazed by the technical achievement, but she also felt uneasy. The power system had no redundancy built in. There was one primary reactor and one backup reactor. If both failed, the entire station would lose power. Human ships typically had multiple independent power sources. If the main reactor failed, backup reactors could take over. If those failed, emergency batteries could keep life support running. There were backups for the backups. Kolnath noticed Lisa's expression and asked if she had questions. Lisa carefully asked about emergency power systems. The engineer seemed offended by the suggestion that emergencies were likely. Kolnath explained that proper engineering eliminated emergencies. The reactors were built to such high standards that failures were essentially impossible. Planning for failures would be admitting that the engineering was imperfect. Jake was beginning to understand the architect mindset. They built things to be perfect and expected perfection to be permanent. The idea that perfect systems might still fail seemed impossible to them. But Jake had been in space long enough to know that nothing was ever permanently perfect. Accidents happened. Equipment wore out. External forces caused damage that no one could predict. Human engineering philosophy was different. Humans expected things to go wrong eventually. They built systems that could handle failures gracefully. When one part broke, other parts took over its job. The tour ended in the main observation lounge. Through large windows, they could see space and the distant stars. The view was spectacular, but the room itself was sterile and functional. Velthera asked the humans what they thought of Synthesis Station. Jake said honestly that the engineering was impressive beyond anything humans had achieved. The efficiency and precision were remarkable, but privately, Jake wondered what would happen if something went seriously wrong. The station was perfect as long as everything worked according to plan. But real life did not always follow plans. Lisa was thinking the same thing. The station was beautiful and efficient, but it seemed fragile somehow. It was optimized for perfect conditions, but space was not a perfect environment. As the humans settled into their quarters for the night, they talked quietly among themselves. They had seen amazing things, but they had also seen potential problems that the architects seemed to ignore. None of them knew that in just 3 days, those problems would become deadly real. Jake woke up to the sound of alarms screaming through the station. Red lights flashed in his quarters, and an automated voice spoke in the architect language. He could not understand the words, but the tone was urgent. He grabbed his clothes and ran into the corridor. Other humans were doing the same thing. Lisa appeared at her door looking confused and worried. The alarm was louder in the hallway and hurt their ears. Troy came running from the other direction. He had been working late in the engineering section when the alarm started. His face was pale and he was breathing hard. Troy told them something bad was happening in the main power coupling. The coupling was a critical part that connected the fusion reactors to the rest of the station. It had been working perfectly for over 100 years without any problems. But now it was failing, and the failure was spreading to other systems. Captain Ryan Bell met them at the main corridor intersection. He had been trying to contact the Architect Command Center, but the communication systems were acting strangely. Some channels worked and others did not. Ben Davis joined them with Dr. Amy Parker. Ben had been monitoring the tactical systems when everything went wrong. He reported that the station's defensive systems were cycling on and off randomly. Amy had seen the scientific equipment starting to malfunction in strange ways. The group hurried toward the command center following the emergency route markers on the walls. But they quickly discovered that some corridors were blocked by security doors that had automatically sealed. The doors would not respond to their access cards. This was exactly the problem Ben had worried about. The station's efficient design meant there were limited routes between sections. When some routes were blocked, there were no good alternatives. They had to backtrack and find another way around. The detour took them through parts of the station they had not seen before. These areas were showing signs of system failures too. Lights flickered and air circulation fans made strange noises. When they finally reached the command center, they found chaos. Architect technicians were working frantically at control panels. Displays showed red warning symbols and scrolling error messages. The normal calm efficiency of the station was gone. Ambassador Velthera was standing in the center of the room looking stunned. The ambassador's usual confident demeanor had been replaced by something that looked like panic. Velthera was speaking rapidly to other architects, but the translation device was having trouble keeping up. Engineer Kolneth was at the main engineering station, trying to understand what was happening. Kolneth explained to anyone who would listen that the primary power coupling had developed a harmonic resonance. This was causing vibrations that spread through the power distribution network. Lisa asked to see the technical displays. What she saw made her heart sink. The failure was not just in one component. It was propagating through multiple systems like a wave spreading across water. The architects had built everything to work in perfect harmony. All the systems were precisely tuned to work together with maximum efficiency. But this also meant that a failure in one system could affect all the others. Jake studied the displays and began to understand what was happening. The power coupling had developed a vibration at a specific frequency. This frequency was being transmitted through the power cables to other equipment throughout the station. Because everything was so precisely engineered, many systems were resonating at the same frequency as the failed coupling. The resonance was causing more failures, which created more resonance. The problem was feeding on itself and getting worse. Amy looked at the mathematical models the architects were using to analyze the problem. The models were incredibly sophisticated, but they were designed for normal operations. They were not good at predicting how failures would cascade through the system. Velthera noticed the humans studying their displays. The ambassador asked if humans had any insights that might help. But the question was asked with little hope. Human methods were primitive compared to architect science. Ben had been watching the tactical displays that showed the station's overall status. He could see that the failure was spreading in a pattern. It was following the most efficient pathways through the station's infrastructure. Ben pointed this out to Kolneth. The engineer confirmed that the failure was indeed following the primary distribution networks. These networks carried power, data, and other critical resources throughout the station. Lisa suddenly understood the real scope of the problem. She asked Kolneth about backup distribution networks. Were there alternate pathways that could bypass the failing primary networks? Kolneth looked confused by the question. The engineer explained that backup networks would be inefficient and wasteful. The primary networks were designed to handle all normal loads with perfect efficiency. There were some emergency backup systems, but they were minimal. They could only support life support and basic functions for a short time. They were not designed to run the entire station. Troy asked how long the station could operate on emergency power alone. Kolneth calculated quickly and gave them an answer that chilled everyone in the room. The emergency systems could keep life support working for maybe 6 hours. But the manufacturing systems, defensive systems, and most other functions would shut down immediately, and if the cascade failure reached the emergency systems, even life support would fail. Jake realized they were looking at a potential catastrophe. Synthesis station housed 12,000 beings. If the station lost all power, they would have to evacuate everyone quickly. But the evacuation systems depended on power too. The architects were working desperately to find a solution, but their methods were methodical and slow. They needed to analyze each problem carefully and develop precise solutions. This approach worked well for normal engineering challenges, but it was too slow for a rapidly evolving crisis. Velthera announced that evacuation procedures were beginning. Transport ships were being called from nearby systems, but it would take hours for them to arrive. They needed to buy time by slowing down the cascade failure. Lisa looked at the station schematics again. She could see alternate pathways that were not being used. These pathways were less efficient than the primary networks, but they could work as temporary bypasses. She suggested this to Kolneth, but the engineer rejected the idea immediately. Using inefficient pathways would violate design principles and safety protocols. It could cause even more problems. Jake felt frustration building inside him. The architects were so committed to their perfect methods that they could not consider imperfect solutions, even when imperfect solutions might save lives. Lisa was thinking the same thing. She had spent years working on human ships that were held together with improvised repairs and jury-rigged systems. Those ships were inefficient and ugly, but they worked when it mattered. The alarms got louder and more systems started failing. Emergency lighting came on in sections of the command center as main power fluctuated. Time was running out and the architect's solutions were not working fast enough. Troy whispered to Jake that they should offer to help more directly. Maybe the architects would listen if the situation got desperate enough. Amy was studying the failure patterns on her portable scanner. She could see that the cascade was following predictable paths through the station's infrastructure. If they could break those paths, they might stop the cascade from spreading further. Ben was thinking about tactical solutions. In combat, sometimes you had to accept damage to one system in order to save others. Maybe they needed to deliberately sacrifice some systems to protect the critical ones. The station shuddered as another major system failed. More red lights appeared on the status displays. Whatever they were going to do, they needed to do it quickly. Jake made a decision. He stepped forward and addressed Velthera directly. He told the ambassador that humans had experience with chaotic failures and improvised solutions. They might be able to help if the architects would let them try. Velthera hesitated for a long moment. Accepting help from primitive humans would be admitting that architect methods were inadequate. But with 12,000 lives at stake, pride was becoming a luxury they could not afford. Velthera stared at Jake for what felt like forever. The ambassador's metallic face showed no emotion, but Jake could sense the internal struggle. Asking humans for help meant admitting that architect methods were not perfect. Around them, more alarms started sounding. Another section of the power grid had failed, and the cascade was spreading faster. Red warning lights painted the command center in an eerie glow. Finally, Velthera spoke. The ambassador said the humans could observe and make suggestions, but they could not touch any station systems. Architect protocols forbade allowing primitives to modify their perfect engineering. Jake nodded, but he could see the frustration on Lisa's face. She understood what needed to be done, but she was not being allowed to do it. Observing and suggesting would not be enough to save the station. Lisa asked to see the complete power distribution schematics. She needed to understand all the pathways through the station, not just the primary networks. Koloneth reluctantly provided access to the technical databases. What Lisa found confirmed her suspicions. The station had many unused pathways that could carry power and data. These pathways were designed for maintenance and emergency access, but they were normally shut off to maintain efficiency. Lisa pointed to these pathways on the display. She explained that they could be used to route around the failing primary systems. The power would not flow as efficiently, but it would flow. Koloneth rejected the idea immediately. Using those pathways would violate safety protocols and engineering standards. The power loads would be unbalanced and the efficiency would be terrible. Troy joined the discussion. He pointed out that terrible efficiency was better than no power at all. The station was facing total system failure. Saving some functionality was better than losing everything, but the architects could not accept this logic. Their entire philosophy was based on optimal efficiency. Deliberately choosing inefficient solutions felt wrong to them, even when efficiency was killing them. Jake watched another section of the station go dark on the status display. Time was running out and the architects were still debating protocol violations instead of taking action. Ben had been studying the tactical implications of the crisis. He realized that the cascade failure was following the paths of least resistance through the station's infrastructure. This was exactly what efficient design was supposed to do under normal circumstances. But in a failure scenario, efficiency became a weakness. The failure spread quickly through the most efficient pathways. If the station had been designed with more redundancy and less efficiency, the failure would spread more slowly. Dr. Amy Parker was analyzing the resonance patterns that were causing the cascade. She could see that the harmonic frequency was amplifying as it passed through the precisely tuned systems. Each system it reached made the resonance stronger. Amy suggested that they could break the resonance by deliberately detuning some systems. This would make those systems less efficient, but it would stop them from amplifying the harmful frequency. Again, the architects rejected the suggestion. Deliberately making systems less perfect violated their fundamental engineering principles. The station shuddered violently as the main fusion reactor started having problems. The cascade had reached the power generation center. If the reactor shut down, the entire station would lose power within minutes. Jake realized they were out of time for diplomatic solutions. He made a decision that would either save the station or get them all arrested. Jake told his crew to split up and find access panels throughout the command center. They were going to implement their own solutions whether the architects approved or not. 12,000 lives were more important than protocol violations. Lisa immediately understood what Jake was planning. She grabbed her portable tools and headed for the nearest power distribution panel. Troy and Ben followed her lead and found other access points. Belthara shouted in protest, but Jake ignored the ambassador. He told the architects they could stop the humans after the crisis was over. Right now, they needed to focus on saving the station. Lisa pulled the cover off a power distribution panel and stared at the neat, orderly circuits inside. Everything was color-coded and labeled with mathematical precision. It was beautiful, but it was also fragile. She started disconnecting primary power feeds and rerouting them through secondary pathways. The work went against every instinct the architects had taught her during the tour. She was deliberately making the system less efficient. Troy was doing the same thing at another panel. He was bypassing failed circuits and creating alternate routes for critical data connections. The new routes were longer and less direct, but they worked around the failed components. Ben was working on the tactical systems panel. He was isolating sections that were experiencing resonance problems. This would reduce the station's defensive capabilities, but it would stop the resonance from spreading further. Amy was at a scientific monitoring station. She was deliberately detuning sensitive instruments to break the harmful resonance patterns. The instruments would be less accurate, but they would stop contributing to the cascade failure. Koloneth watched in horror as the humans modified the perfect architect systems. The engineer could see efficiency ratings dropping throughout the station. Power usage was increasing and system performance was declining, but something else was happening too. The cascade failure was slowing down. The resonance patterns were breaking apart as the humans introduced deliberate inefficiencies into the system. Jake was coordinating the effort from the main command console. He could see which systems were still failing and which ones were stabilizing. The chaotic human modifications were actually working. Lisa called out that she needed more cable to complete a bypass around a major failure point. There was no proper cable available, so Troy suggested using communication cables that were not currently needed. This horrified the architects even more. Using cables for purposes other than their intended design was another violation of engineering principles. But Lisa took the communication cables anyway and used them to create a power bypass. The bypass was ugly and inefficient, but it carried enough power to keep critical systems running. Ben found a section where multiple systems were failing simultaneously. Instead of trying to save all of them, he made the tactical decision to sacrifice the least critical ones. This concentrated the available power on the most important systems. Amy discovered that some scientific instruments were actually making the resonance worse by trying to compensate for it. She shut down these instruments completely. This meant losing valuable data, but it helped stabilize the power grid. The station's status displays started showing mixed results. Many efficiency ratings had dropped significantly, but the cascade failure was definitely slowing down. Some sections were even stabilizing at lower but sustainable power levels. Velthera stared at the displays in confusion. The ambassador could not understand how making systems worse could make the overall situation better. Jake tried to explain the concept while continuing to coordinate repairs. He told Velthara that sometimes perfect systems were too rigid to handle imperfect situations. Flexible systems that could adapt were often more survivable. Lisa had moved on to a major power junction that was critical to the station's life support systems. The junction was experiencing severe resonance that threatened to shut down air recycling throughout several sections. Instead of trying to fix the resonance, Lisa bypassed the entire junction. She created a web of smaller connections that distributed the load across multiple pathways. Each individual pathway carried less power, but together they handled the full load. The bypass looked like chaos to architect eyes. Cables ran in curves instead of straight lines. Multiple connections existed where one should have been sufficient. Nothing followed optimal design principles, but it worked. The life support system stabilized and the resonance in that section died away. Troy had found the source of the original cascade failure. The main power coupling was still resonating, but he could not shut it down completely without losing too much power. Instead, he created a dampening circuit using spare components from maintenance storage. The dampening circuit absorbed some of the harmful resonance and converted it to heat. This reduced the coupling's efficiency, but it stopped the resonance from spreading. By working together, the humans had created a network of bypasses, dampening circuits, and alternate pathways throughout the station. None of their modifications were perfect, but all of them worked well enough to serve their purpose. The station was no longer optimally efficient, but it was stable. The cascade failure had been stopped and critical systems were functioning. Most importantly, 12,000 lives were no longer in immediate danger. Kolneth stared at the modified systems with a mixture of fascination and horror. Everything the humans had done violated architect engineering principles, but the results were undeniable. The station was still running. Ugly and inefficient, but running. 3 days had passed since the crisis ended, and Synthesis Station was still running. The emergency was over, but the repairs continued. Human modifications were scattered throughout the station like scars on a perfect face. Jake found Velthara in the observation lounge staring out at the stars. The ambassador had been spending a lot of time here since the crisis ended. The perfect confidence that had marked all architect behavior was gone. Jake sat down near Velthara without speaking. Sometimes silence was better than words. The ambassador would talk when ready. Finally, Velthara turned away from the stars. The ambassador's metallic features seemed different somehow. Less rigid and more thoughtful. Velthara spoke quietly about the modifications the humans had made. The ambassador had been studying them for 3 days, trying to understand how they worked. The mathematics of it made no sense according to architect principles. Jake explained that human engineering was not based purely on mathematics. It was based on experience with systems that broke down and needed to keep working anyway. Humans expected things to go wrong. They built their systems to handle partial failures and unexpected problems. This meant accepting lower efficiency in exchange for greater reliability. Lisa joined them in the lounge. She had been working with Koloneth and other architect engineers to understand what had happened during the crisis. The collaboration had been difficult at first but was getting easier. Lisa sat down and pulled out her tablet. She showed them a comparison between the station before and after the human modifications. The efficiency ratings were lower across almost every system, but the reliability ratings told a different story. The station could now survive multiple system failures without cascading into total breakdown. Individual components might fail, but the overall system would keep working. Velthera studied the data and asked how this was possible. Lisa explained that the human modifications had introduced redundancy and flexibility into the rigid architect design. Multiple pathways now existed for critical functions. If one pathway failed, others could take over the load. The pathways were less efficient individually but more reliable collectively. Troy and Ben arrived with their own tablets full of data. They had been analyzing the cascade failure to understand why it had spread so quickly. Through the original architect systems, Troy explained that the architects had optimized everything to work in perfect harmony. This harmony was beautiful and efficient, but it also meant that failures could spread through harmonic resonance. The human modifications had deliberately broken this harmony by introducing different frequencies and dampening circuits. This made the systems less elegant but more stable. Ben added that the original design had too many single points of failure. Critical systems depended on individual components that had no backups. When those components failed, entire sections of the station lost power. The human modifications had created alternate routes around these critical components. Now, if one component failed, power and data could flow through different pathways. Dr. Amy Parker came in carrying a thick report. She had been studying architect engineering principles and comparing them to human methods. Her findings were surprising even to the other humans. Amy sat down and opened her report. She explained that architect and human engineering represented two completely different philosophies about how to build things. Architects tried to eliminate all sources of inefficiency and waste. They created perfect systems that worked flawlessly under ideal conditions. This approach produced amazing results when everything went according to plan. Humans accepted inefficiency as the price of reliability. They built systems that could handle imperfect conditions and unexpected problems. These systems were messier and used more resources, but they were harder to break completely. Velthera asked which approach was better. Amy said that both approaches had advantages and disadvantages. The best solution might be to combine them. Captain Ryan Bell had been listening from the doorway. He came in and sat down with the group. Ryan had been thinking about the implications of what they had learned. Ryan pointed out that the galaxy was not a perfect place. Asteroids hit space stations. Solar flares disrupted equipment. Wars damaged infrastructure. Real-world conditions were chaotic and unpredictable. Perfect systems worked well in perfect conditions, but real conditions were rarely perfect. Imperfect systems that could adapt to changing conditions might actually be more practical for real-world use. Kolneth appeared in the doorway looking hesitant. The architect-engineer had been struggling with the concepts the humans had introduced. Everything Kolneth had learned about engineering was being challenged. Jake invited Kolneth to join the discussion. The engineer sat down stiffly and began asking questions about human design philosophy. Kolneth wanted to understand why humans deliberately built inefficient systems. Lisa explained that the inefficiency was not the goal, but rather a side effect of building for reliability. Human ships carried extra fuel and backup equipment because space travel was dangerous. The extra weight reduced efficiency, but it also meant the ship could survive equipment failures and still make it home. Human cities had multiple routes between important locations because transportation networks sometimes failed. Having alternate routes meant traffic could still flow even when the primary routes were blocked. Human factories could produce different products because markets changed and customer needs evolved. The flexibility to adapt was worth the cost in reduced efficiency. Koloneth slowly began to understand. The engineer asked about the trade-offs involved. How much efficiency was it worth giving up to gain reliability? Troy said there was no universal answer to that question. It depended on the specific situation and what risks you were willing to accept. For a luxury cruise ship, efficiency might be more important than reliability. Passengers expected comfort and low costs. If something broke, they could call for help. But for a deep space exploration vessel, reliability was more important than efficiency. If something broke far from help, the crew needed to fix it themselves or they might die. Amy added that biological systems had solved similar problems through evolution. Living creatures were incredibly inefficient compared to mechanical systems, but they were also incredibly adaptable and resilient. A human body used far more energy than a robot to perform the same tasks. But human bodies could heal from injuries, adapt to changing environments, and continue functioning even when parts of them were damaged. Velthara had been quiet during this discussion, but now the ambassador spoke up. Velthara admitted that architect philosophy had never considered the possibility that inefficiency might sometimes be beneficial. Architect culture valued perfection above all else. The idea that imperfect systems might be superior in some situations was difficult to accept, but the evidence was undeniable. The human modifications had saved Synthesis Station when perfect architect methods had failed. Over the following weeks, something remarkable began to happen. Architect engineers started incorporating human design principles into their repairs and new construction. They did not abandon their pursuit of efficiency, but they began balancing it against reliability and adaptability. New systems included backup pathways and redundant components. The changes were subtle at first. An extra power cable here, an alternate data route there, but gradually the modifications became more extensive. The final result was a hybrid station that combined architect precision with human adaptability. It used more resources than the original design, but it was also much more resilient. When the Galactic Council reviewed the station's performance after the crisis, they were amazed. The modified station had better safety ratings and higher reliability scores than any previous architect construction. The Council asked for detailed reports on the human modifications. Soon, other species throughout the galaxy began incorporating human design principles into their own engineering projects. Jake stood in the observation lounge one last time before the Columbia departed. The station looked different now. The perfect geometric lines had been softened by the addition of curved pathways and redundant systems. It was no longer the mathematical perfection it had once been, but it felt more alive somehow. More capable of handling whatever challenges the universe might throw at it. Velthara joined him at the window. The ambassador thanked Jake and his crew for what they had taught the architects. The lesson had been painful but valuable. Jake said the humans had learned valuable lessons too. Architect precision and efficiency were impressive and worth striving for. The key was finding the right balance between efficiency and reliability. As the Columbia undocked and began its journey home, Jake thought about what they had accomplished. They had not just saved a space station. They had changed how an entire species thought about engineering. The galaxy's most advanced engineers had learned that perfection was not always perfect. Sometimes the best way to build something was to build it a little bit wrong. And sometimes the most efficient system was the one that was still working, when all the perfect ones had failed.